A beam of light converges at a point P. So let us assume that this is a point P and a beam of light is converging at this point from the left hand side. And what if we keep concave lens and convex lens? The first is convex lens of focal length 20 centimeter, and the second case we have got a concave lens of focal length 16 centimeters. So here f is equals to plus 20 centimeter, and here f equals to minus of 16 centimeter. Now the distance between these two is 12 centimeter, that is given. So we have to find out where will the beam converge. So in the first case, we will use the lens formula, that is 1 by f equals to 1 by v minus 1 by u. Here object is virtual, that is light was coming to that point, but now it is obstructed, so it is virtual. So 1 by f is equals to, in this case, that is in convex case, 1 by f is going to be 1 by 20. 1 by v, we have to find out 1 by v, and u is 12 centimeter plus or 12 centimeter. So here solving this, we will get a value of 1 by v as 2 by 15 or v as 7.5 centimeter. So what we see here is that, and it is at 7.5 centimeter away from the lens of this convex lens. Now in the second case, we have got a concave lens. Here again, we have to find out the distance, where will the light converge. So here again, we will use the lens formula, that is 1 by v, 1 by f equals to 1 by v minus 1 by u. Now the focal length in the case of concave lens is negative. So we will use 1 by minus of 16 centimeter equals to, we have to find out the image distance, 1 by v minus object, that is virtual, and it is again 12 centimeter away from the pole of the lens. So, and the distance is going to be positive, so we will use 12 centimeter over here. Now solving this, we will get 1 by v is equals to 1 by 48, that is v equals to 48 centimeter. So again it would be 48 centimeter to the right of the lens, and in the first case it was 7.5 centimeter to the right of the lens. Thank you.